Hey, welcome to my AI series on a game called StackIt. In the game of StackIt, two players place boxes on a square board and stack them on top of each other until eventually these towers fall over and make territory. And the goal of the game is to own the whole board. The way this works is if a player can place a box either on his own stack of boxes or on an empty field. And as soon as there's 5 boxes stacked on one field, the tower will fall over into all 4 directions, top, bottom, left and right. While the tower falls over, these boxes spread into the neighboring cells, making them your own. If the cell was previously occupied by an opponent, the box just falls on top of his stack and makes it your own. So the only way to win over fields that contain boxes of your opponent is to stack next to them and make your tower fall over onto the opponent's area. And I chose this game in the AI series because I think it will be a nice example of how to implement this really simple game from scratch. And then we will start out with a really simple AI, a min-max search, some alpha beta pruning, maybe a little bit more like there will be a lot of symmetry, so hash tables might be nice. And after that I want to see if that AI is actually able to beat me, and then I want to dive more into Monte Carlo tree search and see how does Monte Carlo tree search play against min-max and which one is stronger. And eventually, and that's also the inspiration for this, I want to see if I can do something similar to AlphaZero. So we would have a neural network combined with Monte Carlo tree search playing itself until it gets really good at the game. Maybe it will find really strong patterns or moves. So I'm really interested to see that going. So here you can see my GitHub. Please take a look at this repository. I will update it as we go along. And here I already made an empty repository and started out a little bit. As you could see from my GitHub, there's commits from, now you cannot see it here because I'm in the README, but there's actually commits from 5 months ago. This is kind of when the idea started. But now I actually have time to do something. So let's just start out with an empty script. So to explain the game maybe a little bit more, let's assume we have a 3x3 board like this. Like this. So now players could take turns and place stones on them. Let me mark this one as the red player placed 1 stone here, and then let's have the blue player place 1 stone here. And now it's back to the red player. Red can now not put a stone on the blue player's field because you can only place on your own boxes or on empty fields. So let's assume the red player stacks, I don't know, up to 4 boxes onto his own field, and in the meantime the blue player is a bit more adventurous and stacks 1 with a red opponent, like this. So in this case, if it's red's turn, now red can actually put another box into the middle, which would cause this tower to fall over. So he would place another box, then it's 5. The tower actually falls over, so it's back to 1, and it would fall on top of the blue stack and color it red, and then fall into all the other directions as well and color it red. And this is the output. Now, one thing you might immediately see, maybe this was not the smartest choice, because now blue, by just stacking on top of his own boxes, has an advantage over the 2 red boxes here, and red cannot catch up. So yeah, anyway. How do we start out? Let's first create a board class. This will be our board, and we have an init function where we actually define a field. Let me call it also board. And this will be initially I will implement it in pure Python data structures. Later on, when we get to the AIs, we might need to switch this. Then I will experiment with NumPy and others. So now I'm going to hard code. This is a 5x5 board. This is what usually the standard board will be. So let's start out with a board, and then because just having a board is a bit boring, let's also make a print function, which prints out our board and board. Yep. Sometimes I tend to narrate what I code. Maybe that's a bit annoying, but bear with me. So for every row in our board, then we field in row print field, and maybe let's make a space in between so it's easier to read. And then let me just code this up, and then I'm gonna narrate a little bit what's happening. I think this should actually work. And let's see if there's some Python overhead. Maybe there's a mistake already. So this now should print a board. Bam. The name is not defined if we have yeah, it's a bit late. Okay, this is our empty board. It's printing. Nice. Now, because just having a board is a bit lame, we probably also want a move function where we can do board move, and then let's say we want to place on field 1, 1, and then something should happen. So def move xy. This belongs here, and then says board x. So here I need to make sure to put y first and then x second, because as you can see, if we iterate over this board, we are actually starting out with the rows instead of the columns. But I think as a human, it's a bit more intuitive to have the x-axis be horizontal. Yeah, I need to save that, and so yeah. And now I need to check if something happened. Yep, here you can see now we moved. So now we can actually display moves. This is still quite boring because actually this move really doesn't belong to any player or anything. So if I were to just move on field 1, 1 twice, it just increments this, but actually we want to implement something like players. So one thing I'm gonna do is I'm gonna player maybe is better. So I'm gonna store the current possession of a field in a separate array. And for now we're gonna hardcode that we only have 2 players in the game. So as soon as we increment this, we also need to set this to current player. And then we want to switch the current player. So this would now switch the player, and in order to make it visible, do I still have this? Nope. In order to make it visible which player it is, I want to introduce something like colors. For this I have to go to Stack Overflow though. You already see, I looked this up before, but I always forget again, like how do you actually print some colors to make it neat and visible. Here we have warning, fail, and end color. Let's take all of those. This one will be player one color. Yeah. This one I don't need. Player 2 color and end color. So this is the terminal way of displaying color. So here now what we do is player actually now we need the coordinates. So this one would be y and this one would be x. And okay, this is more or less so enumerate gives us the index of the current field that we are in. So this board is a list of lists. So as soon as we iterate over the first, second, and third list, we get the index as well. So now we can index the player array. And if player board player one color and is and if the player is 2, we do player 2 color and end color. So what this does now is every time we read a field, we check is it player 1? If yes, we print it in player 1 color and player 2 color. So color plus our field is an integer, so in order to combine that, we need to now do this plus board. And then we will always do an end color because we want to make sure. So if we now run our game, we see, oh, we have two red. So now we can actually distinguish people. Let's see if we get 2 different colors. We get green and red. This is what we expect. This is what our players are going to look like. Let's take a sip. Next, since we can do this now, maybe we pack this functionality into a simple test. Test move, maybe. Value at 1. Let's do it like this. Value at 1 should be 0. Player should also be 0. And then we do board move 1. And now our 2 asserts this should be 1 and this should be 1. Okay. Just move something like this. We keep our main function. So now we have a simple test, and if I execute it now, it will fail because we don't have those move functions. So let's the function value self x y. I kind of want to have some simple tests so that later on, if I change the implementation of the board, I can make sure everything still works, and then we can have different boards like the Python board, NumPy board, bit boards, who knows. This might be over-engineering for now, but as we go along, I think it's not a bad way. So I do no checking here. This is just up to me. Y, X, and player invalid syntax, or somewhere root self dot come on. List object is not callable. Okay, yeah. I cannot name my function same as the structure that I'm storing it in. So I'm gonna be, it's not very, maybe like this to keep it more Pythonic. Like this. Okay. This test now works. Let's just check that the conditions actually break if we change them. Okay. So one thing I want to do is I want to have two moves. In succession. Before I check anything here, it should be now. This is just for later. This one should be 2, just to see that we have can have a separate player. And this may be a bit hard to see now. Okay, it doesn't crash. Everything is good. This works. The next thing we want to do is make sure we cannot move on top of each other. So yes, not board. So if there's a player at xy and actually not equals now we just take a general exception later on. We might want to write our own so we can properly catch it or something. So what happens here, if we do this, we should now see an exception. Cannot move on top of another player because we move to 1-1 and then the other player tried to move on that. Let's also capture this in a test move on top of the player. And what we do here is we do this, we try accept. This is a really bad way of testing it. I should use a proper test framework that supports asserting that something fails. And then oh shit, I cannot even do it like this. I'm gonna look up how to do this better for the next episode, but so actually let's try, can we do PyTest on this file? Oh yeah, it works. We ran 2 tests, both of them passed. Okay, nice. So I guess one of the last things we might do for this episode is actually falling over. In order to support falling over, I will probably do a helper method, otherwise it becomes cumbersome of testing that. This will be a class method from custom board. This will be a class. Now let me think. This will be a bit ugly, maybe. Maybe I'm just gonna leave this for now. What we're gonna do is board. We're gonna no. I want to be able to pass it a custom board. Otherwise, what happened? So I recorded this video a couple of times before, and what happened there was that now I want to try and create a case where we have 4 boxes, and we place the 5th box and it falls over, and there's a couple of cases that I want to test. So I don't want to have a bajillion moves here. So what I actually want to support is a custom constructor where we get back a board. Maybe something like this. We make it. What would be the proper way of doing, I feel, is that our init function should be able to be past the board and the players array and the current player. Or just a board. No, the board and players array and the current player. And then we would make another function, which is the standard, initialize standard board. Why I don't want to do it is because every time we start the game, we would have to do from standard board, which is a bit annoying. So I want to have custom board as the special case. So what happens here is board. We just call the empty constructor, and then we do board. And then we have a board. This is confusing. Board equals board. Oh god. Maybe instance board instance dot player equals. So current player. Currently, we also only support 2 players. This, like later on, we could make it that we have 4 players or something to make it more fun. But for now, 2 players should be fine. So the player array would be an array of. It has to be passed with the board. There's no real way around it. Or is there? For now, maybe I'll remove this method later. Okay, so now we have our function which can create a custom board, I hope. Let's try that. This can go. And board from custom board, and then here we want let's say 3 by 3. Something looks off. This one should be enough. And then let's just do, I don't know, 5 already knows way too much about the implementation. Anyway, so player 1, board, player, current player, also current player is 1, or print. So let's see what this prints. Yeah, so now we have actually 5 over there. And what I now want to do is create a board where we have something like this. I don't know, doesn't matter. So we have 5s in every corner. I think this will help us now build our throw over function. So we want to start throwing over when it's more than 5. And what we will do is, let's start easy. Yeah. X equals 5. So as soon as it's 5 stones, we want to take this and set it to 1, and then, okay, this is gonna be the simple version, and 2 every time. Okay. So board is gonna be plus equals 1. Okay, this one's gonna go. So we go 1 up. We go 1 up and put 1 box on top of that stack and color it in the current player's color. And here we go 1 down, and here we go 1 up. This and here we go 1 down. This should actually be an easy not complete implementation of this. So in this board, we print it first, and then what we do is board move, and then say 0, 0. We move in the top left corner, and then let's see what happens. Bam! 6. Oh, I put 5 everywhere. Funny. Okay. This can never happen, of course. Okay. I didn't save it. Okay. And what you can see now is that it didn't work as we expected it, and I had this before. So what happened is when we try to go 1 up and set it, we actually wrap around and set it down here. And when we try to go 1 left and set it, we actually wrap around and we set it on the other side of the board. And the next thing we can see is, of course, this chain reactions don't work yet. But this will be nice. We can immediately wrap this into our test dev. Test throw over move. So I will fix this part, and I think then this is enough for this episode. We never executed this, did we? How do we know it works? Huh. Okay, and here we actually, for now, we're gonna work with prints, but then we assert the board where you add 2 x2 y0 equals 4 and equals 2. So this should be the top right corner. And as we can see, this fails. So let's check this with PyTest. Okay, it fails. We expect it to be 4. It is actually 5. This because it wrapped, and also 0, 0, but 2. And here we expected. Yeah, let's wrap this. Okay. One thing that is actually not well defined in the rules is if you throw something over that's at the corner, does it fall off the grid? Does it bounce back? There's many ideas that we can implement there. Currently, I'm aiming for it just falls off the board and is gone. Okay, in order to avoid this, and this is the last thing that we're gonna fix is we check if a coordinate is in the board, return 0 smaller equals x smaller than 0 and 0 smaller equals y smaller than board. So x needs to be smaller than the length of the first row. I assume that all the boards will be squared. I mean, I don't know. I could do something different, but I won't. And y needs to be smaller than the length. So, and here we can now do in board x, 1 plus 1. And we have this one, oops, this one, 2 up, then minus, and then 2 up, plus 1, minus 1. Let's check. Unexpected indent. Okay. Forgot to indent. Our name board is not defined. Okay, yeah, I need to put board here. Self board. Okay, now our test passes, which if we just execute this with Python and then actually we print it again and we just execute with Python, and now we see, oh yeah, now it falls over correctly. It doesn't wrap around the array. And in the next episode we will continue and build chain reactions. And then I think after that we are already at a state where we could start implementing the Minimax API. So thank you for watching and bye.